Okay, so starting off with trig ratios. Okay, so we're going to work with sine, cosine, tangent today. All right, this is the intro to trigonometry. Now, trigonometry is always going to be dealing with right triangles. So I have a right triangle right here, okay, and it's got different pieces, right? You have a side length of A, okay, another side length of B, okay. These two are what we call my legs, okay. These two are what we call my legs around the right angle, and then this is the hypotenuse, okay. So you've got three sides, right, and then you have, of course, three angles because it's a triangle. So we've got the 90 degree, okay, and then we've got my other two, x and y. Now these are less than 90, okay, because, you know, the triangle has to add up to 180. So keep that in mind, right? We got the 90, and then we got the two other ones that are less than 80, okay? They could be the same, but they don't have to be. Just something to keep in mind. All right, so just starting off with some vocab to begin with. So let's talk about the word adjacent. So the word adjacent in the context of today is going to mean next to or touching. Okay, so for example, if I'm looking at this angle x, okay, if I'm looking at this angle x, then that means that this is going to be my adjacent side. Okay, this is going to be my adjacent side. The opposite is going to be across. Okay, so I'm looking at x here. A is going to be my opposite side. Okay, now one thing I do want to mention is, yes, technically by the definition of adjacent, when I compare x, C is technically adjacent, right? It is technically next to or touching, but C is my hypotenuse because that's the one that's across from the right angle. So if it's the hypotenuse, it kind of like defaults to the hypotenuse. The hypotenuse is always the hypotenuse. Okay, the difference might be just when compared to x, either this is my opposite or my adjacent, or either A or B are my opposite or my adjacent, depending on what angle I'm comparing it to, right? If I'm looking at x, A is my opposite, okay? If I'm looking at x, B is my adjacent, okay? And if I were to switch it, right, with y, those two would flip. All right, but again, adjacent. We need to understand that it means next to or touching, right? Touching the angle. Okay, and then opposite is across from, and then your hypotenuse is that one across from the 90-degree angle. All right, so filling in some of the beginning trig ratios. Okay, now I'm going to go ahead and give you the definitions. All right, but essentially what it is, right, is you're just comparing two values, right? We look at an angle. Okay, and then we talk about the different ratios from there. So, for example, sine. Okay, and to talk about it, right, it's technically sine, but we abbreviate it to SIN. Okay, it's technically cosine, but we abbreviate it to COS. It's technically tangent, abbreviated to TAN. So that's what I'm referring to with this right here. Okay, so sine of x. Okay, again, I'm comparing it to x. Okay, sine is always going to be my opposite over my hypotenuse. Okay, always going to be my opposite over my hypotenuse. Okay, so anytime I'm looking at the ratio of sine, okay, depending on what angle, okay, it's going to always be my opposite over my hypotenuse. So we just always compare those two relationships. Get out of here. Good. Okay. Cosine. All right, cosine is always going to be comparing my adjacent over my hypotenuse. Okay, and notice, right, we have a dividing sign here. Yes, you can think about it as a fraction, but at the end of the day, it's dividing, right? It's a number divided by a number. Okay, so cosine of x, again, the adjacent side, which is next to, divided by my hypotenuse. All right, and then tangent is just comparing the opposite side over the adjacent side. All right, and that is going to be consistent, like throughout. Every time we are working with sine, sine is going to be equal to the opposite over the hypotenuse. Cosine is going to be equal to the adjacent over the hypotenuse. Tangent is going to be the opposite over the adjacent. That will remain consistent. Okay, the only thing that changes is comparing to what angle, which one of these angles we are looking at. Okay, all right. So let's go ahead and start filling this in. All right, with actual letters. Okay, so sine of x, let's not ruin it for each one. Okay, but sine of x, so I'm looking at x. Again, I always start at my angle. I'm comparing it to the angle. Okay, Well, and what I'm trying to do is I'm trying to find what is my opposite side when compared to x. Okay, again, when compared to x, I go straight across, A is my opposite side. Okay, you can see how it's kind of opening up here, right? So A is my opposite side. So I'm going to put A on top. There it is. Okay, the hypotenuse, well, the hypotenuse of my right triangle, that's always going to be the one directly across from the right angle. There it is. That's my hypotenuse. So this particular one, sine of x, just filling it in with, general letters, okay, sine of x is equal to A over C, because, again, it's the opposite over the hypotenuse. So compared to x, again, compared to x, compared to one of the angles, it's the opposite over the hypotenuse. Okay, so that it would be A over C in this particular one. All right, on this next one, let's see. See if we can guess it. Hopefully you didn't see it that time. Okay, we've got cosine of x. All right, cosine of x. Okay, so again, I'm comparing it to x. I'm comparing it to one of my angles. All right, and I have the adjacent side. Well, what is my adjacent side? Well, this is my opposite side. That's my hypotenuse. That's my adjacent side. So compared to x, it's touching. Okay, it is touching. It is next to or touching. So here it is. Okay, so I'm going to put B on top, and that's what I have. Okay, B on top, good. And then my hypotenuse remains the same. It was C in the other one, right? And it is still C here. All right, so that is cosine. And then my last one, tangent. I'm comparing the opposite over the adjacent. Well, compared to x. Again, compared to one of those angles. We're picking x this time. It's my opposite, which is A, okay, over B, which is my adjacent. Okay, again, compared to x, it's the opposite over the adjacent. So I've got A over B. Cool. Okay, now very similar process, but this time we're going to compare it to y, right? It doesn't matter which angle you could compare it to. We can write trig ratios for each one if we know those sides. Okay, so let's go through each one. All right, I'm not going to kind of hide it from you this time. All right, but sine of y, okay, comparing it to y this time. Notice it's still my opposite over the hypotenuse. Guys, sine is the comparison between the comparison when comparing it to an angle between the opposite over the hypotenuse. Okay, cosine, adjacent over the hypotenuse. Tangent, opposite over the adjacent. That is the definition of those words. Okay, it is comparing, the opposite over the hypotenuse, or et cetera, et cetera. All right, and each one is different. Okay, so sine of y. Okay, now I'm looking at y. Now notice, big change, right? I was looking at this angle compared to this angle. So everything changes, right? Everything changes because now what's my opposite side compared to y? Okay, see, now it changes, right? So when compared to y, the opposite is b. Okay, so now the opposite is up here, right? The opposite side, the opposite side was always going to be on top, but this time the opposite side is b as opposed to a, right? Opposite side of x was a, that's why a is on top up here. Y, opposite side was b. Okay, but the hypotenuse stays the same, right? The hypotenuse doesn't change depending on what angle you're comparing it to. Cosine of y. Again, I'm comparing it to this angle up here, all right? It's the adjacent. Well, this time my adjacent is this one right here, all right? My adjacent side is the one that's touching, all right? So cosine of y, adjacent, it's equal to a, right, over c, okay, because c is my hypotenuse. Tangent of y. Tangent of y. So again, comparing to y, okay, tangent is equal to the opposite over the adjacent side, all right? And we've got the opposite is b, adjacent is a. So that's why we have that right there. Again, the vocab, this vocab, extremely important, extremely important. So adjacent, and that means next to or touching. It's the one that's literally making one of those angles, right? So if we were to go back and compare it to x, just to review this word adjacent. If we were to say which one is adjacent, okay, when compared to x, right? Yes, technically this is adjacent, but that is my hypotenuse, okay? So this is my adjacent side. It's the one that makes one of those angles, right? I can't have this angle without that side B. Opposite is that one straight across, okay? Again, not touching, right? If I were to think about the angles and the sides that make this, right? If I'm looking at this one right here, right? This angle, these are the two sides that make this angle. Well, the opposite one is the one that has nothing to do with it, okay? So that's one way to think about it. And then the hypotenuse, again, remains the same. Sometimes maybe you draw like a little arrow, right, to show, right, you locate your 90-degree angle, and you see that the hypotenuse is directly across. All right, so that's an introduction to trigonometry. Let's go to the back. Okay, let's look at this page. Okay, the way to remember this, all right, the way to remember this is this right here, SOHCAHTOA. You'll hear me say that a million times. Like, you have to know this. It is the most common way to remember the trig ratios. Okay, now, you do have to remember how to spell it. Let me just go ahead and say that, right? So, SOHCAHTOA, all right, that's how we say it. It's SOHCAHTOA. Now, these just stand for the words that we just talked about. It's sine, and here's how you say it, right? So sine is equal to the opposite over the hypotenuse. Now let's look at it. That's exactly what we just said, right? That was exactly what we learned in the very beginning. So if I'm looking at it, sine is equal to the opposite over the hypotenuse. Okay, and that's what we have here. Sine is equal to the opposite over the hypotenuse. All right? And then cosine is equal to the adjacent over the hypotenuse. Tangent is equal to the opposite over the adjacent. So these 9 letters, have to know them. Okay, I'll probably post this silly like video where this dude is dancing and like singing this song. Okay, but it's important, right? You have to know this in order to even begin to work with trigonometry. All right. So now let's look at an example where we're actually working with some concrete numbers. Okay, now we have real concrete numbers, and immediately when I see that I'm working with sine, cosine, tangent, me personally, I like to just write SOHCAHTOA out. Okay, sometimes I split it with lines. I don't always do that, but sometimes I do. Okay, maybe when we're learning, right? It's good to have it. Okay, and I'm going to just write it there just so I have it to reference. Okay, so then I got it out of my brain, and it is there so I can work with it, right? I don't have to remember it each time. I put it there. Now I've got it to reference. Now I can say, oh, in case I forget what sine is, I've got it right here. Sine is equal to the opposite over the hypotenuse. Okay, in case I forget cosine, cosine is equal to the adjacent over the hypotenuse, etc., etc. Okay, so in order to write sine of x, okay, well, here we go. All right, we're just going to write sine of x, and we don't know what x is, but we're just going to write sine of x. Okay, sine of x. Well, what is sine? Sine is equal to the sine of the angle, right? I should always say, right? It's always sine of the angle. Okay, don't lose sight of that. The original trig ratio is sine of the angle, okay, equals the opposite over the hypotenuse. So let's go ahead and label it. Okay, let's start off with comparing it to x, right? So let's go ahead and label my sides. Okay, compared to x, 3 is my opposite. Okay, so I'm going to write O. Okay, compared to x, 4 is my adjacent. All right, and then compared to x, since this is my right angle, right, this is my hypotenuse. Okay, so I now have those 3 letters labeled, okay, to where now, if I just understand that sine of x is equal to the opposite over the hypotenuse, O over h. Okay, so it's equal to 3 over 5. That's my trig ratio. That's what sine of x is equal to. Sine of x is equal to 3 over 5. Now, could this be a decimal? Sure, could be. Okay, so we'll go ahead and write the decimal. There it is. Okay, 3 over 5 is equal to the decimal 0.6. All right, so on to the next one, cosine of x. Cosine of x. Okay, we're still comparing it to x, so these letters still stand. Question is, what is cosine? Well, cosine is the adjacent over the hypotenuse. So here we go. The adjacent is 4. I'm not going to write the opposite over the hypotenuse, that stuff. I'm just going to write the numbers this time. Okay, that's 4/5. All right. Well, that's equal to 0.8, but that is your trig ratio. That is what cosine of x is equal to in this particular one. Now, notice, we don't know what x is. Okay, we're going to do that stuff, that sort of stuff later. Just keep in mind, x is an angle. Okay, x is an angle measure, and this is a real triangle, right? The lengths of 3, 4, 5 could make a right triangle. All right, but for now, we just don't know what x is, and that's okay. Tangent of x. All right, tangent of x. So I'm, again, comparing it to x. Tangent is equal to the opposite over the adjacent. Okay, again, opposite over the adjacent. So this one's going to be 3/4. And if I've labeled everything, then it makes it relatively easy. I'm just using the letters, right? So tangent is equal to the opposite over the adjacent. Opposite, which is 3, over the adjacent, which was 4. Okay, so this is equal to 0.75, right? Both of those are okay. I do want you being comfortable with the fractions, okay? But decimals are gonna play a big part with trigonometry. All right, let's do the other one. Okay, so comparing to sine this time, sine of y. Okay, sine of y. Now, when we compare it to a new angle, we do have to consider, we've got to change up my letters. So I'm going to go ahead and just get rid of all my letters just in case. Just so we can completely start over. Okay, so with y, comparing to y, right? I'm trying to find sine of y. So I've got to start at my angle. I always link my angle first, right? Start at the angle. Find the angle that it's referring to. So angle y, okay? And then the opposite of angle y is going to be 4, right? It's a cross, right? Here's the sides that make that angle. Here's the sides that make that angle. Straight across is O. Okay, here's the sides that make that angle again. This one is what? That's my hypotenuse, so I'm going to go ahead and label that one. And then this one is my adjacent. So now I have new letters when I'm comparing it to y. Okay, and again, from here, now that I have it labeled, I just, apply those values. So I'm at sine of y. Okay, sine is equal to the opposite over the hypotenuse. I'm using my acronym, right? This is called an acronym, right? When it stands for, it's like a one word that stands for different letters. Okay, so I've got sine is equal to the opposite over the hypotenuse. So I've got 4 over 5. Okay, 4 over 5. All right, and I'll box it, and I know that that's equal to 0.8. If you'll notice, those two end up being the same. Just throwing that out there. All right, cosine of y. Okay, so cosine of y. Well, I know cosine is equal to the adjacent over the hypotenuse. Okay, so cosine of y, comparing it to y. Adjacent, that's my adjacent side, over the hypotenuse. So this is 3 over 5 when compared to y. And that's going to be equal to 0.6. And you should notice a pattern. Okay, on tangent of y. Tangent of y. Here we go. Here's y. Always start at your angle that is in the trig ratio, and then you just go to SOHCAHTOA. Opposite over the adjacent. So I've got 4 over 3. And that's going to be about 1.3 repeating. All right. So that is an intro to trigonometry. At the end of the day, it's just a... Whoa, why is it paused? Okay. Luckily, I finished.